so let's start out with our two different types of variables. So you've thought about x and y as input and output variables. Now we're going to put fancy words to them. We're going to call them our independent variable and our dependent variable. So whenever we're talking about the independent variable, we're talking about the x value. And whenever we're talking about the dependent variable, we're going to be talking about the y value. Okay, because if you think about it, are you guys independent or dependent of your parents right now? You're dependent. You're living under their roof. You might be working and paying your own bills, but you're still living under the roof possibly. So you'll be dependent of them. Independent means that I can make that x whatever it is I want. Doesn't really matter about the y. So I could pick whatever number I want to put in for x. I could pick 1. I could pick 2, 3, 4, 5, 6, 7, 8, 9. I can put whatever number I want in for x, and then whatever number I do put in for x will affect the output, which is the y. So independent variable is x. Your dependent variable is going to be the y. Okay? So when you have a bunch of independent and dependent values, you have something that's called a relation. And a relation is a set of ordered pairs. So any set of ordered pairs I can come up with is going to be a relation. So this could be an example of a relation. So I could have the set of -2, 1, 1, 2, 3, 4, 5, 6, and so forth. Having any set of ordered pairs would be a relation. This would also be a relation. 1, 1, 1, 2, 1, 3, 1, 4. You don't necessarily need to have 4 numbers. You could just have one set of numbers. Okay? So, relations is just a set of ordered pairs. So up here, which values would be my independent variables? 5. What would be the dependent variables? 1, 2, 4, 6. Down here, my independent variables are just 1, or is just 1. My dependent would be 1, 2, 3, 4. We have special names for those. Remember what they're called. One starts with a D. The other starts with an R. Domain and range. Good. All right. Go back. Where is this? There it is. Domain and range. So your domain is going to be the set of all your x values, and your range is going to be the set of all your y values. So if I had the relation of -3, 4, and 5, -7, keep it small, what would be the domain? Yeah, and you usually just go smaller to largest. So the set of -3 and 5. What would be my range? Yeah, and just go smallest to largest. So list the -7 first, and then 4. So my range would be the set of -3 and 5. Did I say domain or did I say range? My domain is -3 and 5. My range is the set of -7 and 4. Okay. Now, do we remember what makes something a function? There it is. No repeating x values, right? To determine if something is a function, we want to look at those x values. Let's go back and get that up. So a function is a relation. Every function is a relation, but not every relation is a function. your head around that a few times. So a function is a relation. And for each value of the first component of ordered pairs, which are your x values, can have only exactly one value of the second component. So a relation in which for each value of the first component of ordered pairs, there is exactly one value of the second component. Okay, so we're looking for first component, x, to be paired with only exactly one value of the y. So first component, x, second component, y. All right, so is relation f a function?
Yes.
I agree. Do I have multiple ones? No. Do I have multiple negative twos? No. Do I have multiple threes? No. So my x terms are not repeating. So this is a function. What's the domain? So my domain is, negative 2, 1, 3. I won't mark it incorrect if you don't put them from smallest to largest, but you should get in the habit of doing that. What's my range? Yeah, negative 1, 2, and 4. Okay. Can someone add a fourth ordered pair on there that would not make it a function? 1, 3, 1, 6, that would work. Negative 2, negative 5 would also work. 3, 7 would work. Good. All right, so let's look at one that's not. So would this be a function? All right, I guess that one is, huh? So negative 2, negative 1, negative 1, 0, 0, 1. That is a function. Here's one that's not. So negative 4, negative 1, negative 2, 1, negative 2, 0. So this is not a function.
So then no x value can be the same?
Correct. No x value can be the same. Because your first component needs to have exactly one pairing with a y component. Well, here negative 2 is paired with 1, but negative 2 is also paired with 0. Can't happen. Okay. And they might give it to you in a table format also, which just would be that you can't have repeating x values in your x column.
In the definition that you gave us for a function, you said there's exactly one value for the second component instead of the first.
Yeah, that's what
Was it?
confused me. Yeah.
Yeah.
It's confusing.
That's not right. Let me go back. The definition. First component of the ordered pairs, there's exactly only one value of the second component. Yep.
But didn't you say the second component was y and the first component was x?
Value of the first component of ordered pairs, there's exactly one value of the second component. For each value of the first component of the ordered pairs, there's exactly one value. Right, so it's only getting paired with one value of the second.
Then you have to move the comma. Because how that says there's only one value of the second component.
Why is it
How's the book have it written? I feel like it's the way the book is. Let me see here. Hold on. Let's get our English out there in the world. Where are my Lang people? A function is a relation in which, for each value of the first component of the ordered pairs, comma, there is exactly one value of the second component. Do we need to write the textbook about their comma?
They just wrote it really confusing.
They did write it really confusing.
Probably just write a letter then.
Write a letter?
Yeah.
I'll work on that this weekend with all my free time. Okay. Huh? What? Instead of writing your test? Alright, so we talked about domain and range. There's another way that you could possibly see functions, and this is called a mapping diagram. So if you see a function or a relation as a mapping diagram,
Go do it.
your domain values are going to be on the left side bubble, and your range is going to be on this right side bubble. So in this case, my domain would be the set of 1, 2, 3, 4, and my range would be the set of DBA or ABD if you went in alphabetical order. Would this be a function?
Yes.
Yes. If I wrote this out as an ordered pair, it would be 1 comma D, it would be 2 comma B, it would be 3 comma A, and then it would be 4 comma A. Do I have any repeated X values? No. I can have repeated Y values. I just can't have repeated X values. Justin?
So if it was like 1D, 1B, 2B, 3A, 4.
Yeah, so if I put another arrow coming off of the 1, like this, then that would not be a function. Okay? So I can have 2 arrows going to one range, but I can't have 2 arrows coming from one domain. Okay? So given an ordered pair, set of ordered pairs, you should be able to identify whether something is a function or not. Given a table, you should be able to identify whether something is a function or not. Given a mapping diagram, you should be able to identify whether something is a function or not. So how do we determine whether a graph is a function or not?
Find a few points on it, and
You could, but how many points are on that graph?
then many.
Infinite many, right? All right, well, let's first just focus on the domain and the range. So if you want to make a quick sketch of this graph, just put that top point at 0, 4 and make a V going downward.
So it would not be a function.
Nope, well, 0, 4 is the only 0, 4 on that graph. There is no other 0, 4.
That's 2 points because it's 2 lines.
Nope.
I don't think
That's still just one line. All right, so let's talk about the domain of this graph. It's easy to recognize domains when you're given a set of ordered pairs because you just pull out the X numbers. And the range, you just pull out the Y numbers. But here I have a continuous graph, which means I have infinite numbers of points on the graph. So, X coordinates correspond with the numbers on your X axis, correct? So if I think about my x-axis as going, that's an ugly color, let's change that one, go green. If I think about my x-axis going left to right, does this line ever stop?
No.
So what's the furthest x value that this line's going to hit? Negative infinity, right? And on the right side, what's the furthest right x coordinate that my graph is ever going to hit? Positive infinity. So my domain is what? Negative infinity to positive infinity, which is the same as our all real numbers, right? Does the book want us to do set notation? Oh, let me quickly check that. 2 seconds. Nope, nope, they're using interval notations, that works. So now let's do the same thing for the range. Your y-axis goes up to down, or down to up, whichever way you want to think about it. So when we do x, we start smallest to largest. Where's my smallest value on a y-axis? Top or bottom? The bottom. Do I ever have a bottom of this graph for my y's? As this line goes out, will my y coordinates ever stop? No. As this line goes out, will my y coordinates ever stop? Nope. So they're going to keep on going all the way down to what? Negative infinity. Now let's think about where it goes towards the top part.
0.
It's stopping at what y coordinate? 4. So for my range, it's going from negative infinity to positive 4.
Yes.
So how do we determine whether it's a function? It is. I'm sure this is on a slide somewhere. Do you guys remember the vertical line test? So the vertical line test you use to check if there is a relation is a function or not. And you're looking for one vertical line to intersect the graph in more than one spot. I guess I should one point, not spot. So you're looking for one, all you need is just one for it to intersect in more than one point for it to not be a function. So if I draw a whole bunch of vertical lines on this graph, will there ever be a line that intersects it more than once? No. So this is a function. Yeah, yeah. So if we had, can I get rid of this? So let's just go through a few examples. You don't have to write these in your notes. So if I had a parabola, would that be a function? Would that pass? Yes. If I had this kind of graph, would that pass? No. If I had just points, let me do different colors so we can see it. If I had a point here and a point here and a point here, would that pass? No, because that vertical line passes through more than 2 points. If I had this as my graph, would that pass? No. Would this pass? No, that would not pass. Would that pass? Yes, right? Because it doesn't go more than once. Would that pass? Yeah. Okay, a linear equation is a function. So, using the vertical line test, you should be able to determine whether something is a function or not. Is this one a function? No. It's just another ellipse going long ways. Yes, because relations do have domain and ranges. So let's practice that. So this is not a function. So now we can still identify the domain and range.
Domain is -2, 1, 0, or -2, -1, 0, 1, 2.
So remember, domain is going from your x to your left to right. Is this continuous? Yes, it is. It's continuous. So what's my furthest left x? What's my furthest right x? Does it include -2 and 2? So bracket or parenthesis? Bracket -2 to 2. Got the brackets. Now remember, your y goes bottom to top. What's your most bottom y? Top y. So bracket -5 to +5.
Why don't you write all of them out?
Huh?
Why don't you write all of them out?
Because it's continuous. You can't possibly write them all out. Because then you would be doing -2, -1.9999999, -0.9199999, -0.1999, and so forth. That would be impossible to do. Okay, because it's continuous. It's going on and on forever. Okay, so given a graph, we should be able to do the domain. What will be the domain of this graph? We won't write it down. Arrows. So does it ever stop? Does it ever stop? So my domain would be -∞ to positive infinity. My range would be negative infinity to,
2.
well, it never stops, so it keeps going higher and higher and higher.
Okay, that makes sense.
So the only time it's going to stop is when you have something that is blank. What about this parabola? What would be the domain? Yep.
And then would it be
And then what's the range?
or 1?
Work bottom to top. Negative infinity to positive 2. Is that a bracket or a parenthesis?
Oh, that'd be 1.
Oh, yeah, it is 1. And a bracket, right? Because we're including the point at 1. So negative infinity to positive. All right, so we've got that. The last thing we need to cover is function notation. Will we get to that? Maybe not.
Yeah, I don't want to get to that.
All right, so we might have to take off some problems. You will have to do these, though.
Down.
If I give you the equation y equals x plus 4, what would that graph look like? That would be a straight line. Is that a function?
Yes.
Yes. So this is a function. Yes, a function. What would be the domain of a straight line? Yep, we just looked at it. And what would be the range? Negative infinity to positive infinity. Good. What if, I think the next one was, y is equal to the square root of x plus 4? Would that be a function? If I plug in 1, well, let's plug in something that's nicer. Let's plug in 5. If I plug in 5, 5 plus 4 is 9. The square root of 9 is 3. If I plug in 4 here, is there any way to get anything else other than 3? No. So I'm not going to have multiple x or multiple y values when I plug in 3. Does that make sense? So if I just plug in 5, I'm not going to get 3. I'm not going to get negative 3. I can't get 1. I can't get negative 2. I can't get any other number but 3. So because it doesn't matter what I put in here, it's going to be a function. So yes, a function. Now how do I identify the domain and the range? Is there any restriction to what number I put in here? No. So my domain is going to be, now let's think about this really quickly. If I plug in, let's say, negative 5, what do you get? Can I get the square root of a negative 1?
Technically,
Yeah, so think about this. What is the smallest x value I could put in here to get an actual number? Not 0. Negative 4 would get you 0, right? Anything smaller than negative 4, I'm not going to be able to get that out. So whenever you get a square root sign like this, x plus 4, it needs to be greater than 0, which means your x needs to be greater than negative 4. How do I write that out in interval notation? How do I write x is greater than negative 4? Or equals to, I guess. We could have equals to. Bracket, negative 4 to infinity. The range would be what? Is there any way that this is going to end up being a negative when I take the square root of something? Can I get 0 for y? Yes. Can I get 1 for y? 2. Technically I could, right, if I pick the right x values. So my range in this case is going to be 0 to infinity. All right, so let's do this. Let's revamp maybe some of these problems.